complicated cooking show.
Today's topic, toast.
You wonder why your bread is so fluffy? Well, it starts when you add honey, yeast, and warm milk or water together. Yeast is a dormant one-celled organism. When added to the milk and honey mixture, it begins to reproduce. The honey provides something for the yeast to eat, which allows it to produce more quickly. To allow the colony of yeast to reproduce to its fullest, you have to wait around 5 minutes. Now that the 5 minutes has passed, notice how fluffy and light the yeast mixture looks in comparison to the granules that it was when it first started. Active dry yeast is a leavening agent used in baking bread. As yeast begins to eat away at the sugar that was added, it begins to multiply. That's why it looks so puffy. Basically, it converts the fermentable sugars present in the milk and sugar mixture into CO2 and ethanol. As the bread rises, it traps the CO2, ethanol, and steam in little pockets. As it's baked, the temperature increases, and so does the volume of gas, causing the bread to explode. The bread is about to go in the oven. It looks pretty much the same, but the one on the left has yeast in it, and the one on the right does not.
So as you can see, it's fairly apparent that one of these looks has risen and one is not. The reason this one has not risen is because it doesn't have yeast in it. So gluten is a natural protein found in the endosperm of a wheat grain. Now, when you combine gluten with water, it becomes highly elastic and allows the bread to retain gases, which is why the bread has risen as opposed to this one, which hasn't. Now that the bread is made, we're going to have to do something with it. No, the bread is boring. So, we are going to make toast. Now, toasting happens because of the Maillard reaction. The Maillard reaction is a combination of carbohydrates and proteins. Now, carbohydrates contain simple sugars and proteins contain amino acids. And when exposed to heat, such as a toaster, they react and break down. A toaster transfers heat through radiation. This is good for bread because it allows there to be no moisture. Now, this doesn't work for a microwave because a microwave keeps the moisture in the bread, which keeps the Maillard reaction from happening. So, the heat from the toaster gets rid of all the moisture and reaches about 310 degrees, where the amino acids and the carbohydrates react until the carbohydrates break down into simpler and simpler sugars until the surface of the bread actually compromises. This reaction produces many black bugs, which cause the caramel color, smell, and taste that we associate with toast. So this toast is perfect, and this one, not so much. This one cooks too long. And the reason that it turned black is because during the toasting process, the Maillard reaction is technically burning the ingredients on the chemical level. So heat applied to this one was enough so that the carbohydrates actually carbonize, forming a layer of pure carbon on the outside. Most people don't want to eat pure carbon on the whole. So now that we made this wonderful bread, all there is left to eat it. So I guess we'll cut this. What are we going to do with this one? Really? the end.